Welcome to the channel Maths for Gadgets. Today we'll start a brand new topic, residue. So let's start. Suppose we have function f of z and z equals to z naught is an isolated singularity. Since z naught is an isolated singularity, so there exists a deleted neighborhood of z naught in which function is analytic at each point. Let me write the neighborhood. So we have a deleted neighborhood modulus of z minus z naught less than r, and r is some positive number. Okay. Since function is analytic in this neighborhood, so we can write Lorentz expansion of the function f of z around z naught. So Lorentz expansion is f of z equals to summation n is from 0 to infinity a n z minus z naught raised to power n plus b1 over z minus z naught plus b2 over z minus z naught square and so on bn over z minus z naught raised to power n and so on. Okay. Here this part is known as analytic part. Now here comes the important part, residue of function f of z at the isolated singularity z naught. This equals to coefficient of 1 over z minus z naught, and here we can see coefficient of 1 over z minus z naught is b1. Okay. So this equals to b1, which is residue of function f of z at point z naught. Okay. Now let's do some problems. So we have a question here, find residue of function f of z at z equals to minus 3. Okay. And function f of z is z plus 3 whole square into sine 2 over z plus 3. Okay. All right. So to find residue, let's expand this function. Okay. Writing the expansion of function f of z. So we have f of z equals to z plus 3 whole square and expansion of sine 2 over z plus 3 will be 2 over z plus 3 minus 2 over z plus 3 whole cube over factorial 3 and so on. Okay. Now multiplying this z plus 3 whole square inside this bracket. So we have 2 z plus 3 minus 2 cube will be 8 over factorial 3. Factorial 3 is 6. Okay. And we have z plus 3. Okay. And this so on. Okay. So here residue of function f of z at point minus 3 will be coefficient of 1 over z plus 3. Okay. And here we can see coefficient is minus 8 over 6, right? So we have here minus 8 over 6. After simplifying, we'll have minus 4 over 3. So this is the required residue for function f of z at point z equals to minus 3. Okay. Okay. Let's do one more problem. In the second question, we have function f of z is e raised to power minus 2 over z square, and we have to find residue at point z equals to 0. Okay. Alright. Now let's again find the expansion of function f of z. So f of z equals to e raised to power minus 2 over z square. Okay. We all know the expansion of e raised to power z. Okay. So using that we can write the expansion of e raised to power minus 2 over z square, right? So writing the expansion, 1 plus minus 2 over z square plus minus 2 over z square whole square over factorial 2 and so on. Okay. Simplifying, we will have 1 minus 2 over z square minus 2 square will be 4 over factorial 2 is 2 into z raised to power 4. Okay. Okay. So we have expansion of function f of z. Okay. Now residue of function f of z at point 0, it will be coefficient of 1 over z. Okay. And we can see here in this expansion there is no term of 1 over z. Okay. That means coefficient of 1 over z is 0. Okay. So residue of function f of z at z naught is 0. Okay. Now this video ends here, and I have a quick announcement to make. Those students who are preparing for exams like CSIR NET, GATE and other MSc entrance examination can buy our complex analysis handwritten notes for a very reasonable price for only ₹50. Okay. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.